In this video, we'll be looking at a couple applications of logarithmic functions. Our first application has to do with the decibel. The decibel is defined as d equals 10 times log of I divided by I sub t. Notice that's our common log base 10 in the formula there. D is equal to the decibel level of the sound. I is the intensity of the sound measured in watts per square meter, and I sub t is the intensity threshold of the least audible sound a human can hear. And for average humans, that I sub t is equal to 1 times 10 to the negative 12th. We want to calculate the approximate decibels associated with a sound so loud it will cause instant perforation of the eardrums. That happens when I is equal to 1 times 10 to the 4th power. We'll round our answer to the nearest hundredth. They gave us the equation to use. They've given us I sub t, and they've also given us I. All we need to do is plug these two numbers into the formula and then into our calculator. We have d equals 10 times log of 1 times 10 to the 4th over 1 times 10 to the negative 12th. We could plug this into our calculator as is. Just make sure to put parentheses around the numerator and then parentheses around the denominator. Personally, I do a little bit of cleanup though. My life would be so much easier if I just said 1 times 10 to the 4th is 10 to the 4th. And similarly, 1 times 10 to the negative 12th is 10 to the negative 12th. That'll be much easier to plug into the calculator. 10 times log of 10 to the 4th over 10 to the negative 12th. We plug this into our calculator, and we get d to be equal to 160. There's no unit on this because the d, the decibel, is the unit. So we're saying decibels equals 160. Our next application has to do with the magnitude of an earthquake. The magnitude m of an earthquake is measured using the Richter scale. And the Richter scale says that m is equal to 2/3 times log of E divided by E sub 0. Again, that's our common log. M is the magnitude of the earthquake. E is the seismic energy released by the earthquake in joules. And E sub 0 is the energy released by a reference earthquake. And E sub 0 will always be 10 to the 4.4 joules. On May 3rd, 1996, Seattle experienced a moderate earthquake. The energy that the earthquake released was approximately 1.12 times 10 to the 12 joules. Calculate the magnitude of the 1996 Seattle earthquake using the Richter scale. Round to the nearest tenth. Now, again, we have our formula. We were given E sub 0, and we were also given E. All we need to do is plug this into our formula and then into our calculator. We get m to be equal to 2/3 times log of 1.12 times 10 to the 12th over 10 to the 4.4. Now, unfortunately, there's not much cleanup we can do in that numerator. When you plug it into your calculator, be sure that you put parentheses around the numerator. You can either type it in like this, or if you feel comfortable with your exponential notation button on your calculator, you can use that as well. Typing into our calculator and then rounding to the nearest tenth, we get m to be equal to 5.1. This is a moderate earthquake. Major earthquakes are, 9s and 10s, so this would be a moderate one. Again, there's no unit on this. It's just the magnitude is a 5.1 on the Richter scale.